Right, so in spatial sampling, you're emphasizing where the sample is located. And so you use it when data are distributed across space. Everything occurs somewhere in space. And so in so many ways, everything could be spatial sampling. But obviously, the emphasis is on where and what it is, as opposed to just on whatever it is. So when you're choosing your sampling method, you're considering the location of the population and the distribution of the sample within the population. And so say it's a city and you're sampling people in the city, you would want to consider the wealthy parts of the city as well as the less wealthy parts. You'd want to consider people that are living in the commercial district as well as people who are living in the residential district, right? You would need to consider everybody and try to figure out where people are. You want to consider the homeless people. Are there homeless camps? Are there homeless shelters? Those kinds of things, right? So you're considering distribution as well as location. So where is the sample included in the method? Geographic data are either discrete or continuous, right? So we know this, we tell you this all the time. Discrete things tend to be points, continuous things tend to be lines. Discrete things tend to be points, continuous things are much more likely to be rasters, or much more likely to be in a polygon, a tile, right? So it depends. And so you are then thinking, well, what is it that I am collecting? Well, what am I collecting? How am I going to collect it? Spatial data, point samples, area samples, polygon samples, or linear samples. So I put traffic flow there for linear samples. I've put pollution content in a stream on a linear sample. You might also choose, I've talked about doing a transect, you might also choose to create a linear sampling method and then collect points along that. You might choose to have a parcel or an area of vegetation and then choose points within that. All right, so you can muddle these up, and that's perfectly okay. You're going to do what's best for you. You're going to do what's best for how you're going to do it. So there at the bottom, I say some things are both discrete and continuous, right? Temperature data are continuous, and we map them continuously, we graph them continuously, but we actually collect them every single hour at a single location. So, think about what it is that you're sampling. And obviously my examples are much more physical examples because that's what I do. Haha. Random sampling means that you're collecting a random location within your study region. Very often you'll lay a grid on the map, and then which is sometimes called a fishnet, and you can create a fishnet using ARC. It'll just use a tool for that. And then you use a random number generator to select the location. So you might put on a grid, you might assign each block in the grid a number, and then you use a random number generator between those number ranges, and you select one. Then you go to that location, and so once you get there, you go to the coordinate of the location, or you go to the approximate location in the middle of your grid area, and you choose there to select. And so some people, if it's vegetation, for example, will have this PVC rectangle, and they'll kind of throw it over their shoulder and see where it lands. And then, wherever it lands, as long as it's flat, you go ahead and sample that. My husband famously threw one and it landed like 2 feet from an alligator's nose. So then you change it, right? So we say that these are random, but of course safety and practicality indicate that, in fact, they might not be truly random. Don't get eaten by an alligator. That was in the Everglades. Systematic is this regularly spaced pattern, and you're much more likely to do something systematic if you're looking at the how of a landform, how a landform has grown, or if you're trying to collect over different elevations, and you might have a transect that goes up the hill and then down the other side. Or you're looking at a river, because a river is an elongated feature. If you're collecting river data, you don't want to just randomly select. You're much more likely to need to be systematic, moving along the stream. So stratified, again, depends on how the population is structured. So before I used an example where you had a city and you had maybe 60% of one race and 20% and 20% of two different races. Or maybe it's age, or maybe it's socioeconomic status, some kind of stratification. And if they are in defined geographic regions, then you would sample within those defined geographic regions. So you may have, a 60% residential area, but you know that there are people living in a commercial area as well as an industrial area. And so then you would break it out stratified according to those geographic subregions. More weight would be given to the 60%, right? You'd want 60% of your sample to come from the 60% of the region. Linear is a form of systematic, right? So you're moving along a linear feature. And again, the methods don't have to be mutually exclusive. You could decide to have a systematic method and then you select random points based on the line or on the systematic method. So you don't have to just choose one or the other. And here's some examples, right? So in the top, can you see my mouse? I don't really know. In this top green box, you've got random, systematic, or stratified. On the stratified, you can see these little dots that break the region of the rectangle out. And so the bigger region would have more points in it. Over to the left, you've got a grid that's been placed onto this geographic feature, some kind of landform that you've got here with rivers and I don't know what. And the grid's been placed and every top left is a point, right? And so it's systematically located. Every single top left has a point in it. Alternatively, you could randomly choose to put points anywhere all over. And so in the third image, you've got these dots that are kind of anywhere and you don't see any kind of pattern to it. And how did they decide where they were? Well, they could have literally pulled coordinates and chosen those different coordinates from anywhere. In the fourth one, it's kind of a combination. You've got the grid and you've got 2 points in every single grid cell. And maybe you'd select every one of those points, or maybe you'd select a random number of those points. But I think it's intended to show that you could have like a combination of things. It definitely doesn't look stratified to me, although you do have more points along the river and you do have more points along the pale area that you have there. Spatial stratified sampling, to focus on that, the population is not homogeneously distributed, and so the sampling shouldn't be either. And so you do more sampling in areas where you know that you've got more interesting data or more problem areas, problem in quotes, not necessarily a problem. The space is divided into substrata, right? So you're going to separate out and then pull your sample from those. And you need to ensure that you sample sufficiently in those subregions. So high density of population, high density of trees, you're going to sample. So the subregions could be, they could have a totally separate method, right? So they could be a regular distribution or an irregular distribution of points in that subregion. Sampling could be systematic or random or a combination. How are you going to figure your sampling locations? Well, it depends. There are ways of creating this fishnet inside your ARC product, right? And so whichever product it is, it's going to be able to do that. And fishnet might be called something different. You're layering on a grid. And then you can create random points as well. So ARC allows you to do these kinds of things. And so it's inherently spatial. It's inherently useful to that. You can also have grids and gradicules added. It might not be called that anymore, but if you search grids and gradicules, then you'll be able to add that. So this is going back to what before field work, and we talked through all of that. That's the exact same slide. During your field work, you want to set up before the fieldwork as well, you want to set up a workflow that you will carry out during the fieldwork, right? So you are, I would want you to decide, okay, how am I going to do it? What am I going to do? What are my methods that I'm going to figure through each step? What if you run out of power? What if you get a layer and it just doesn't work? What if it all goes wrong? I would like you to think through those things. And truly, if it all goes wrong, pieces of paper are usually very, very useful. While you're actually doing the field work, you want to save frequently. Can you back everything up? Perhaps, perhaps not. Beforehand, you want to consider battery life. Nowadays, it's so easy to get battery, external battery. That's all new and different, right? So you're very lucky. Consider the weather. Synchronize as soon as possible or download your data as soon as possible. Look at your results. Sometimes you will find that as you're actually moving through the data collection, you should change it. And so it's not unusual to modify what you're doing as it goes along. After the field work, which of course might be at the end of every single day, or even at lunchtime on every single day, you'll save or download or synchronize or backup or whatever it is. It is really easy to copy over your older data, so keeping your files organized is essential. Looking at your results, transcribing your notes, clarifying anything that's necessary. If you're not using the camera on the device, then make sure you've labeled the photographs you've taken so that they match up with whatever sampling method you're using, numbering system you're using. Do you have enough? Did it work? Right? These are all terrifying questions, especially if you can only go to your field site once. Okay, that's the end. Ta-da!